Good morning, students, and all our viewers from wherever you're watching us from. Welcome to today's lesson, Mathematics for Form 4s. With me, I'm teacher Elphas Ndenga, and I will be taking through one of the topics in Form 4, which is longitudes and latitudes. I believe you are well conversant with this topic. You've looked at it in detail, and so today we are going to make a summary of it and look at important areas that we need to prepare as candidates. One thing that I will say before we start the lesson is as you prepare in mathematics, you ought to know that a mathematics student has to be ready. And one of the things that you have to be ready with are simply the resources that you need to have. As a candidate, then, I believe that you are prepared and you are well furnished with the following requirements that we need in mathematics, so that when you are revising, you should always have them. The very important one is a calculator, because that is one of the requirements that the Kenya National Examination Council requires us to be able to use in an examination room. You must also be having a mathematical table, which is also very, very important. And always when you're revising mathematics, ensure you have a geometrical set so that when you have cases for constructions, you can be able to apply them. Above all, a good mathematics student has to ensure that he maintains high level of accuracy, because at the end of it all, the accuracy mark is what will count. But then also, we look at how you approach the question, and that's why we say this is a very simple subject, because we allow you to get marks from step by step. With that then, let's look at what we need to discuss today. And our topic today is longitudes and latitudes. We are discussing longitudes and latitudes. So that is for Form 4. The topic is longitudes and latitudes. Longitudes and latitudes. The basic information that we ought to understand in this topic is to know what are longitudes and what are latitudes. That is the basic foundation of it all. Then once we've understood what are longitudes and latitudes, we then design them to what we call the circles. And so in our lesson today, I want us to focus on two main areas. Our two main areas that we need to focus on is, number one, we are going to discuss simply the position of points on the Earth's surface. The position of all points on the Earth's surface. Then number two, we are going to calculate distance. We are going to calculate distance along a great circle, and number two, along a small circle, So those are the areas that we need to look at in our lesson today. But before then, I want us to first have a review of what are longitudes and what are latitudes, so that we can now be able to see how exactly we need to calculate all this. If we draw the circles, if we draw the Earth, and from your geography, you know that the Earth is spherical. We have this as the North Pole. This is the North Pole. This is the South Pole. Then we have the line joining the North Pole and the South Pole, which we are calling the Earth's axis. This is the Earth's axis. And then at the center, there is a circle. There is a circle at the center. This is the circle that is greater from all other circles. And this circle is called the equator. This one is called the equator. This circle is called the equator. The equator being a circle, then we definitely must be able to see the diameter. That is the diameter of the equator. And so from this point then to this point, we get what we call the radius. That is the radius. And then there are other small circles. There are other small circles that are running this way. They are perpendicular. Their plane is perpendicular to the Earth axis. These other circles, just like the equator, their plane is perpendicular to the Earth axis. And you know what it means by perpendicular? They make 90 degrees with the Earth axis. So these circles that are perpendicular to the Earth axis are what you're calling the small circle, and they are constituted by the latitudes. They are constituted by the latitudes. For example, we can be able to locate this point if we draw this, and then we will have an angle theta at that point. Equally, we can draw this to this point and have another angle. Let's call this angle beta. And then have this as our point A and this as our point B. Then you'll be able to see one thing, that from the point O, if this is our center O, to A, we still have this as the radius of the Earth. From O to B, this still remains to be the radius of the Earth. And so we want to say one thing in this case. If this is the center and this, we have the point here, let's call this point X, then AX will be an arc. AX will be an arc of the circle. This one is an arc of the circle. And this circle is the circle that is subtending an angle, the radius subtending an angle theta at the center. Equally, XB is an arc. This is also an arc of the circle. And this arc of the circle subtends an angle beta at the center of the circle. And so from Form 1 topic, there's a topic in Form 1 called length. We say, when talking about the arc length, or the length of the arc, the length of the arc of a circle is given by theta over 360 2 pi r. 2 pi r. That is how we get the length of the circle, the length of the arc of the circle in Form 1. And so that is what you are going to apply here in the calculation of this length from A to X, equally also from X to B, when you are determining the length of the arcs AX and XB. And so we will consider that, but then because they are small circle, there is a radius R. So that if I drop a perpendicular line from this point to this, so that I have this point now, this becomes the small radius R. Remember, the radius R, capital R, is the radius of the Earth. And we are all aware that the radius of the Earth is equivalent to 6370 kilometers. That is the length of the radius of the Earth, 6,370 kilometers. So we are going to apply this when we'll be looking at our second part, where we'll be calculating the distance around either along the small circle or a great circle. So in short, latitudes are simply the imaginary lines that are drawn and whose plane, is perpendicular to the Earth axis. Their plane is perpendicular to the Earth axis, and they form what we call the small circle. So we say latitudes, these ones are measured. They are measured to the north or south. They are measured to the north or south of the equator, meaning the equator is the point of reference. When you're looking at the equator, becomes the main point of reference for latitudes. So we measure it either to the north or to the south of the equator. And they are given in degrees, remember? They should be in degrees. The angles are given in degrees to the north or to the south of the equator. Once we've known about the latitudes, then let's also look at the longitudes. Now, for the longitudes, there are great circles. This is the Earth. This is the north, and this is the south pole. And then we have the circles that are running now from the north to the south. They run from the north to the south. And they are not measured from the equator, as we do here. We measure the longitudes based on the main meridian line we call the Greenwich meridian. The Greenwich meridian. That is the reference point from which we determine all the longitudes. They are measured from the Greenwich meridian. And so, unlike in the latitudes where we measure to the north or south of the equator, these ones are measured either to the west or to the east of the Greenwich meridian. So we can have a point, for example, if this is now our point O, we can be able to locate the position of different points. Let's say this is point A, this is B, and this is C. And then consider the angle at the center to be theta, and the next angle for A to be the angle alpha. So we've located the angle AB for points A, B, and C, but then they are measured now from the Greenwich meridian, unlike in the other case where we measure from the equator. Here we measure the angles in the, from the Greenwich meridian. So they are simply measured in degrees to the east or west of the Greenwich meridian. That is how we determine or how we locate longitudes. These are for longitudes, and these ones are for latitudes. And so you'll definitely be able to see, if we are to look at this circle, if this is a circle that we are looking at, the whole of this circle, comparing it with this circle, then one of it is larger. This is a larger circle compared to this one. And so we say longitudes constitute to what we call great circle. Longitudes form great circles. They form great circles. And latitudes, on the other hand, they form small circles. However, there is one latitude here, which is the equator. The equator serves as both a small circle and a great circle. So if you are to ask which circle is both a small and a great circle, it's simply the equator. It serves both as a small circle and a great circle. But generally, longitudes constitute to great circles and latitudes constitute to small circles. So that is the foundation of this topic that we need to understand before we get deeper into calculations of what is required to do in mathematics. And so I believe I've been able to break it down for you, and then we can be able to discuss now the main concepts that we are supposed to do in our lesson today. The first thing that I want us to know is, how do we locate positions of points on the Earth's surface? Like a point, if we talk, for example, Nairobi being located on a specific point within on the Earth's surface, how do we look at it based on the longitudes and latitudes? For example, if we talk about a town like Accra being located on the longitude that is 60 degrees north and then 0 degrees, how do we read or interpret this? One thing that we need to know is that we locate position of points on the Earth's surface. Position of points on the Earth's surface. This one is simply done, is located in ordered pair. In ordered coordinate, that is. And that is in terms of the latitude angle against the longitude angle. So we give first the latitude and then the longitude, then we enclose them in brackets. This should be 6 degrees. Sorry, that is 6 degrees north. So if we look at 6 degrees north and 0 degrees east, it defines that 6 is for the latitude. This is the latitude. And this is the longitude. That is the latitude and that is the longitude. That is how we define the points, we locate the points on the Earth's surface. Let's talk, for example, if we are given a point like, for example, Nairobi, and say Nairobi is on 1 degree south, 37 degrees east. This is the location. So it means then Nairobi, its latitude is 1 degree. Latitude is 1 degree south, and its longitude is 37 degrees east. So we can be able to tell from these two towns that in Accra, as one of the town is on 6 degrees, on a latitude of 6 degrees north and 0 degrees. And then on in Nairobi we have 1 degree south and 37 degrees east. That is how we locate. Therefore, it is important to understand in generally that points are located on the Earth's surface, as we have that is alpha degrees against now theta degrees. This could be north or south. This is north or to the south, and this could be east or to the west, depending with the location of the town or the place that you'll be dealing with. So that is how we locate. Then we have now to look at something very important then, which is calculations. We want to see the calculations that are involved in this topic, longitudes and latitudes. So most of the questions that you will be handling will be coming from these calculations. So we can look at what we call distance along great circles, distance along great circles. So that is what we want to calculate and look at a series of questions that have been tested from this part that is of importance to our lesson today. So I've shown you what are great circles. They are constituted by longitudes. They are constituted by great circles. And so what we need to do is let's look at how do we identify 2 points or more than 2 points are on a great circle. And we say that 2 points or towns, 2 points are on a great circle. They are on a great circle if they have or they are on the same longitude, angle, and direction. I will explain what this means, that it has to be on the same longitude, angle, and the same direction. When I talk of the angle is, for example, if it is 60 degrees, then they must all be on 60 degrees if there are 2 points, A and B. If A is 60 degrees, on the longitude of 60 degrees, and 60 degrees also has to be for A. Direction, if it's to the east, then this has to be to the east. If we find these 2 towns, or these 2 points, then they will be on a great circle, because they share the same longitude angle, 60-60, and they are on the same direction of the Greenwich meridian, east-east. So it is quite important to know that we identify great circles by looking at the longitudes, and the longitudes have to be the same angle and in the same direction. So if, for example, let's try to fill this and say this is 30 degrees north, and then say this is 45 degrees north, so that we can be able now to have a complete set of points, A and B. So B is 30 degrees north, 60 degrees east, and A is 45 degrees north, 60 degrees east. This is a great circle. And it's a great circle because they share the same longitude angle and they're on the same side of the Greenwich meridian. Good. So if we know this, then how do we calculate distance along a great circle? That is of great importance. How do we calculate the distance along a great circle? What is happening is, if you look at the diagram that we have here, we have the point, for example, B and C. The point B and C are forming what we call an arc. That is an arc of a circle. And the arc of the circle here is formed or subtending an angle, theta, at the center. And remember, this is the radius of the Earth, which we are saying has a figure of 6370 kilometers. But the question will always give, sometimes it might give 6371 or 6370. So we have to look at the distance along a great circle, because that's the arc length. We said arc length is simply equal to theta over 360 2 pi r. And why do we say this is the calculation? It's because the definition of an arc in itself, an arc of a circle is simply part of the circumference. So if the arc is part of the circumference, then it means it is a fraction of the circumference. And so a fraction of the circumference is constituted by this part, theta over 360. That forms now that part we're calling the fraction. Then this 2 pi r is now the circumference, because circumference is 2 pi r, or simply pi d. But then we are going to substitute this r, because we are not just talking about a normal circle. We are talking about the circle that is formed on the Earth's surface. Even though these lines that we are talking about, the longitudes and latitudes, are imaginary, we tend to believe that they are forming circles. And so we say the length and distance along a great circle, distance along a great circle is calculated in two ways. Number one, in kilometers, because we can have distance in kilometers. So we have the formula theta over 360, then 2 pi. Now we will replace this r with the capital R, the radius for the Earth. That is the value. And so when talk about theta here, theta means the latitude difference. Latitude difference. We talk about this as the latitude difference. R is the radius. This is the radius of the Earth. The radius of the Earth. And the radius of the Earth, we are giving it a figure, a value which is 6370 kilometers. Or some questions will use 6371 kilometers. Then we have a second unit of calculating distance we call nautical miles. Nautical miles. We use nm. A nautical mile is simply a unit that we use to calculate distance that is covered, the longest distance covered by ships and aeroplanes. And so in this case, we talk about the subtension of 1 degree. For every 1 degree difference in the latitude, we cover 60 nautical miles. So that is the conversion that we are going to use, that for every 1 degree change, we will be able to have 60 nautical miles. However, if we calculate the conversion, the direct conversion of kilometers versus when you compare kilometers and nautical miles, we will say that for 1 nautical mile, then that is 1.853 kilometers. That is the conversion rate if we are now changing the nautical miles to kilometers or kilometers to nautical miles. But in the calculation, then we are going to have this kind of situation. So that is how we calculate distance along a great circle in nautical miles and in kilometers. I want also to look at a small circle, then be able to discuss now the questions that we have, so that we can now do it as one. Because you find that these questions that we'll be discussing, they are comprising both a small circle and a great circle together. One question but has both the small circle and the great circle. So it is important I discuss the small circle, and then now we can be able to handle the questions all together. So we have distance along a small circle. Distance along a small circle. First of all, let's look at this circle. This is our circle. This is our circle. This is the equator. This is the equator. This is the radius or the diameter. And then we can locate a circle. We can locate a circle. This is the circle. When we have this circle, we have this as our center. Remember, we've said that for small circles, we measure them either to the north or to the south of the equator, meaning the equator is our foundation line here. So if we locate this, in this case, let's have this as an angle theta. And then I want us to have another radius here, of which I'm going to now call r, small r. And then this becomes the radius. Equally, this is the radius of the Earth. That is the radius of the Earth. And so if we drop this, I want us to obtain a circle, a triangle, sorry. Remember we said that the circles, the small circles are always perpendicular. Their plane is always perpendicular to the Earth axis. Definitely, the Earth axis means the line joining the North and the South Pole. This is the North and this is the South Pole. So that is the Earth axis. And so we want to derive a relationship that we are going to apply in the calculation of small circles. So students, look at this. This is the radius, the small r, which is the radius of the small circle. And this r is the radius of a great circle, the capital R, the radius of a great circle. And so we want to apply a concept in Form 2. Under trigonometry, we talk about SOHCAHTOA. We talk about SOHCAHTOA. For all those who understand the initial, what each of the term, the letters here represent, this is sine, opposite of a hypotenuse. This is the cos, adjacent over the hypotenuse side, and the tan is given by opposite over the adjacent side. So definitely then, we can drop this and obtain a triangle here. I want to have this as my A, this my O, and this my B. So now we have the triangle. The triangle now that we are using is the triangle BOA. That is now the triangle. And at O, we have the angle theta. At O, we have the angle theta. And so this AO is our radius. AO is our radius. And so we will be able to see that AB becomes the opposite side. AB is the opposite side to the angle theta. BO is equivalent to this side, this length, which is R. So this is small r. And so it is therefore easier to see that, or to know that we have, when we given R and R, this is the adjacent and this is the hypotenuse, then we use cos relationship. So we'll say cos angle theta is equals to the adjacent side over the hypotenuse side. So what's the adjacent? It is R. And what is the hypotenuse? It is capital R. And so let's get our R. Our small r then will be, R will be equal to the capital R cos angle theta. So it means the radius of a smaller circle on the Earth's surface is given by R, which is now the radius of the Earth that we know is 6370, cos angle theta. And so what is this theta? That is what we need to understand. What is that theta? So we have to look at the location of these points. I want us to look at the location of the points. And this theta, as you can see, it is defining A. And what is A? A is a latitude. A is a latitude. It's a small circle. So theta here defines A, meaning we can say A is on theta degrees north, theta degrees north. That is the definition, the description of the point A. And therefore, this theta here, this one, is the latitude angle. Latitude angle. And this R is the radius of the Earth. Radius of the Earth. And the radius of the Earth is 6370 kilometers. The radius of the Earth is 63 kilometers. So students, then we can then replace here. We are saying distance along a small circle. Distance in, number one, in kilometers will be theta over 360, 2 pi r. That is the formula for a great circle. So in a small circle, we only need to do some changes here. I want to use an angle alpha, so that I bring this part, substitute it here. So it's a small circle, then this r becomes the small r. But we've already seen that this r is defined by this part. This is the part defining the small r. So we'll say this distance then becomes alpha over 360 2 pi. Instead of the small r, now we replace with r cos theta. That is the formula now. Where now alpha, what we mean by this alpha? Alpha is now the longitude difference. The longitude difference. The difference in the longitude is what we call the alpha. The theta is the latitude angle. Latitude angle. So you can see that the formula is simple. Once you understand the formula for the great circle, small circle, we only add the part for r cos theta, which is the r cos of the latitude angle. Good. So let's finish up then. Distance along a small circle in now the other part, nautical miles. In nautical miles. That is now our part B, distance in nautical miles. Along a great circle, it is 60. We're talking about 60 times theta, because for every change in latitude is 60 nautical miles. So we have 60 theta. And so we are only going to add now, instead of this theta, for our case of our relation here, so 60 alpha, then cos theta, where theta now bringing in this part for the small circle. So this is how we calculate distance in nautical miles along a small circle. This is distance in kilometers along a small circle. This is the formula for calculating distance in kilometers along a great circle. And this is along a small great circle in nautical miles. So with that then, we are now good to go in discussing questions from this concept that we have highlighted in our lesson today. So let's look at one or two cases that we can talk about in a great circle and a small circle. We have a case here, so we can now look at questions. Our first case is that a plane leaves an airport A, which is located on 38.5 degrees north and 37.05 degrees west, and flies due north to a point B, which is on latitude 52 degrees north. The question is, part A, we find the distance. The distance covered by the plane. In kilometers. Distance covered by the plane in kilometers. That is the first part. So the questions on this topic are always very simple. But what is very important for a student to know is how to interpret the question and come up with a very conclusive judgment on whether the points given are on a small circle or a great circle. Once you interpret the question and identify correctly that it's on a small circle or a great circle, then calculations will be very simple, because it's a matter of simply applying the formula. in this case, then, let's read together that the plane leaves an airport which is 38.5 degrees north, that is the latitude angle, and 37.05 degrees west, this is the longitude angle. It is flying due north. It is flying due north to a point B, which is now on a different latitude, 52 degrees north. We can be able to tell that if this point A and B, if this plane, is flying due north, then it is maintaining the longitude, but it is changing the latitude. And that's why you have from 38.5 degrees, we end up with 52 degrees north. And so I can be able to tell that point A, if it is on 38.5 degrees north and 37.05 degrees west, then point B will be located on 52 degrees north and 37.05 degrees west. If this is the case, then we can see these points share the same longitude angle, 37.05 degrees, and they share the same side. They are on the same side of the Greenwich meridian, west-west. So this is a great circle. So if you can identify it's a great circle, calculations become simple. We are told the distance in kilometers. So we say distance equal to theta over 360 2 pi r. 2 pi r. So we will be able to replace in. The theta is the latitude difference. So we get the difference in the latitudes. And A is 38.5 north, B is 52 degrees north. We say if they are on the same side of the equator, then we subtract. The difference here will be 52 degrees minus 38.5 degrees. I say that we need to have resources, so I hope you have your calculators so that we can be able to do it together. 52 degrees with less 38.5, that gives us 13.5 degrees. 13.5 degrees. That is the difference in latitude. And so we replace here and say our distance then will be equal to 13.5 degrees. That is over 360. We multiply by 2, multiply by the pi, which is a constant of 22 over 7, times 6370 kilometers. So if you do the substitution in your calculators, which I believe you're doing, let's do it together. We divide, that is multiply by 2, we multiply by 22, we multiply by 6370, and then we divide that by 7. We obtain our figure, which is 1501.5 kilometers. 1501.5 kilometers. That is the distance between the points A and B in kilometers. Good. Part B of the question, remember it has part A and B. So part B of the question reads that the plane then flies due east to a point C, and the point C is 2,400 kilometers. The point C is 2,400 kilometers from B. Then you're told determine the longitude of C. You determine the longitude of C. Not to say the longitude, but the position. Let's write the position. Determine the position of C. That's a very good thing. Let's interpret together and see how we will be able to unwrap all this. B, the plane is flying due east. From where? From B. Remember, it started at A. It flew to B, and so now it's moving from B to C. So we will be able to identify our B. We are saying the position of B is 52 degrees north and 37.05 degrees west. Now the plane is flying due east to another point. So it is definitely going to retain the longitude angle, and we are changing now the longitude. We are changing now the longitude angle. So C is going to be defined by 52 degrees north. And then we have another angle x degrees west. X degrees west. So now this tells you that B and C are on the same small circle. Same small circle, because they share the latitude angle and they are on the same side of the equator, which is north. So if that is the case, then we are determining the distance along a small circle. In part 1, the interpretation gave us the distance along a great circle. Now here, we are talking about the distance along a small circle. And so how do we calculate distance along a small circle? Distance along a small circle, and it is calculated in kilometers, is the formula we are saying is alpha over 360 2 pi r cos theta. So the first task that we have is to determine what is theta, what is alpha. And alpha means the longitude difference. So I want us to retain alpha in our case so that we determine what is that, because this is the longitude difference, the difference in the longitudes. So I will still use alpha. I will not introduce another constant. Then theta, we said theta is the latitude angle, and the latitude angle here is 52. So we write 52. So we substitute in and say alpha over 360 times 2 times 22 over 7 times 6370 cos 52. And this distance is equals to 2,400. Is equals to 2,400. Again, students, let's do the substitution in our calculators. We work out this side, and then remember we have unknown here, theta, so that we will be able to make it the subject of the formula. So I will replace substitute, that is 2 by 22 by 6370. And then we get the value, divide it by 7. We divide it by 360. And then we multiply this one by cos 52. That gives us a figure which is 68.475. Let's try to four significant figures. So we shall have 40, that is 48. And that is alpha equal to 2,400. Is equal to 2,400. So we can be able to divide. We get our figure for alpha is 35.05 degrees. 35.05 degrees. That is the value for alpha. And if that is the value for alpha, which is now our longitude difference, then we can be able to say, to determine that is the value for x, because what we need to write is the location or the position of the point C. If this is 37.05 and this is 35.05, then the difference between them, 37.05 minus 35.05, gives us 2 degrees. So it means, therefore, that C is located on 52 degrees north and 2 degrees to the west. 2 degrees west. So that becomes now the location of the town C. So we've been able to see, and this question was tested in the year 2000, KCSE 2000, that is the question that was tested. Structured in this manner, we have both the small circle and the great circle all worked out in one question. So with that, we can be able now to know what to do when you're given such kind of a scenario. Let's then look at a second case. We have this question as our question number 2. that the two places, that is P and Q, two places P and Q, they are located on this angle. We have 36 degrees north, 125 degrees west, and then this is 125, and 36 degrees north, 55 degrees east, respectively. Then you're told to calculate the distance, along small circle. Calculate the distance along small circle. Along a small circle in kilometers. Along a small circle in kilometers. We've been told it's very simple. It's along a small circle. Sometimes they will say along parallel of latitude. We will still be referring to the small circle. This defines a small circle because this is 36 degrees north, 36 degrees north. And we have to start with our case. We are saying that the first thing that we get is what we call the longitude difference. The longitude difference. Our longitude difference, we look at the longitudes. 125 degrees west against 55 degrees east. The difference between the two, because this is west and east, we get our difference here will be 125 plus 55 degrees. If you add this, you'll get your figure that is 180 degrees. That is our longitude difference. Once we have this, we'll substitute and say distance along a small circle, is theta over 360 2 pi r. So we will have that is 2 pi r cos alpha, because that's a small circle. So I've only changed this to be alpha, and this one to be our theta. So we'll now have 180 degrees over 360 times 2 times 22 over 7 times 6370 cos of the latitude, which is 36. Cos 36. Again, take your calculators and let's do it together. Substitute these figures. We have 180, we divide by 360, and then we multiply by 2, multiply by 22 over 7, multiply by 6370, and then we multiply by cos of 36. Cos of 36, that gives us 196.52 kilometers. That is 16,196.52 kilometers. That is the distance along that small circle in kilometers. So it's very simple then. As I've told you, it's a matter of understanding the concepts that we are looking at, identifying a great circle and a small circle. Then once you identify the two, get to understand the correct formula to apply in your calculations. Let's take the last case here. This is now a case with 3 points. It has 3 points, and then we need to interpret them very fast and see where we'll be able to reach with the calculations that have been asked in the question. We are told that the position of 3 ports, and the ports are A, B, and C. B and C are with 34 degrees north, 16 degrees west. And then we have 34 degrees north, 24 degrees east. And then we have 26 degrees south against 16 degrees west, respectively. You are told part A, you find the distance in nautical miles. The distance in nautical miles. In nautical miles. The distance in nautical miles between port A and B. Port A and B. Port A and B. Our R that we're using is 6370 kilometers, and the pi given is 22/7. Now, 3 points, different locations, but we can be able to bring them together by looking at their longitudes and latitudes. Let's take an example for A. A is 34 degrees north and 16 degrees west. And B is 34 degrees north, 24 degrees east. This tells you that they share the latitudes. And if they share the latitudes, then it is a small circle. So how do we calculate distance along a small circle? That is what we need to do for part A. Along a small circle, but in nautical miles. So we'll say distance, because it's a small circle, distance along a small circle is simply theta, is simply alpha over 360. That is in nautical miles, sorry. Nautical miles shall have 60 alpha cos theta. 60 alpha cos theta. And so we'll say, in this case, our alpha, which is the longitude difference, this is 16 west, this is 24 east. They are on the opposite sides of the Greenwich meridian. And so we will add 16 plus 24 to give us 40 degrees. And so our calculation will be 60 times 40 times cos. What is the latitude angle? 34 degrees. Cos 34 degrees. So we also replace in your calculators. We have 60, we multiply by 40, multiply by cos 34. That gives us 1989.69 nautical miles. 19.89 nautical miles. That is the distance along the ports A and B in nautical miles. We have port A and C. Port A and C. Port A and C. Port A and C. If you're not to calculate now distance along port A and C, port A and C in kilometers. Port A and C in kilometers. A, where is A? A is 34. Let's look at 34 degrees north, 16 degrees west. And C is 26 degrees south, 16 degrees west. Again, also let's be able to identify whether it's a small or a great circle. The latitudes are different. Longitudes are the same. So this is a great circle. And remember, sometimes you may get a case where if we find this was east, then definitely this will not be a great circle, because this is 16 west and this is 16 east. They are on the opposite sides. So you cannot say that they share the same longitude. For it to maintain that, we must have the same longitude angle and the same direction. So there has to be, if it is west, then the other one has also to be the same angle, but to the same west side again. So this is a great circle. And we are calculating distance along a great circle. Formula: distance along a great circle. Distance along a great circle in kilometers is given by the formula theta over 360 2 pi r. That is the formula. Once we have the formula, then Do we know what is theta? Theta, we've defined it as the latitude difference. So we'll say the latitude difference. Latitude difference. And the latitude difference here is our theta, is equals to, look at the position of the two. 34 north, 26 south. They are on the opposite sides of the equator, so you add. If we had 34 degrees north and 26 degrees north, then they will be on the same sides of the equator, so we shall have to subtract. For this case, we are supposed to add because they are on the opposite side. So we'll say 34 degrees, we add 26 degrees. And if you add correctly, that is 60 degrees. So we replace in our formula then to have 60 divided by 360, multiplied by 2, and our question gave us pi, which is 2 over 7. 2 over 7, we multiply by 6370. Multiply by 6370. We can do our simplification or use your calculator. This is 6, this is 1, this is 910. And so we have this is 1, this is 3, and so we have 22. 22, we multiply by 910, and then we divide it by 3. So our answer becomes 73.33 kilometers. That is the distance. So we shall have calculated the distance along a great circle for these 2 points, point A and point C. So that is what we need to understand in our lesson today. Maybe for the case of our students who are also watching, I want to write one question here, then we can be able to summarize. Now we have the latitude, that is 2 points. That is our question number 4. 2 points, X and Y are such that X is defined by 47 degrees north, and 25 degrees west, and Y is defined by 47 degrees north, and 70 degrees west. We are told to calculate the distance in nautical miles. Calculate the distance in nautical miles. Along the latitude 47 degrees north. That is one of the questions that I want, even before we conclude the lesson, that you'll be able to have and capture so that you can work it out. We also have a case. We have a case also. Now, in question 4, that is, if you look at the position of those 2 points, you'll be able to tell that this is a small circle because they are on the same longitude, 47 degrees north. Therefore, you apply the formula for a small circle. And number 5, you will also be able to practice on this one. We are told that A and B are two points on the latitude 40 degrees north. Then you're told the two points lie on the longitudes 20 degrees west and 100 degrees east, respectively. So you are told to calculate number 1, that is the distance from A to B. calculate the distance from A to B along a parallel of latitude, along parallel of latitude. And then Roman 2, which is something that you need also to understand, is shortest distance from A to B along a great circle, and take pi to be 22/7 and r to be 6370 kilometers. That is the two questions that, as we conclude our lesson, our candidates should be able to practice on. Number one, 2 points x and y are such that x is 47 degrees north, 25 degrees west, and y 47 degrees north, 70 degrees west. Calculate the distance in nautical miles along the latitude 47. And I've helped you to understand that this is a small circle because they share the same latitude. Question 5, A and B are 2 points on the latitude 40 degrees north, meaning they share the latitude 40 north, but the longitudes are different. So A is on the longitude of 20 degrees west, and B is on 100 degrees east. So if you can be able maybe to help you write down, A will be 40 degrees north, 20 degrees west, and then B will be on the location of 40 degrees north and 100 degrees east. So that tells you that is a small circle. So you're told to calculate the distance from A to B along the parallel of latitude. And I already indicated to you when you get the statement along parallel of latitude, then we are calculating along a small circle. So the only change is now part 2, the shortest distance. When talking about the shortest distance, we are calculating the distance along a great circle. So even though the points could be on a small circle, but then they can be calculated along a great circle. And in that case, you must be able to understand that the theta you're going to use is not going to be the latitude difference. Because if you calculate the latitude difference here, it will be 0. So we get the latitude, the difference between the longitudes. And that is the angle between the latitudes, because they are on different ends. You'll find that if you sketch this one, this is a circle. This is the equator. This is our equator. And then let's have this location of point A is to the west. So A will be somewhere here, because this is now 40. Then B is on this side. This is again 40. So that this is now the longitude 100 degrees east. That is now the longitude that we are discussing. Then this one is now the longitude of 20 degrees west. So if this is 40 and this is 40, this is a straight line. Angles on a straight line add up to 180, and therefore the difference in between here will be 100 degrees. So that is what we are going to use as our theta. So we will not use the latitude difference as we have been doing in our cases as we analyze the great circle. So those are the areas that I wanted us to discuss in our lesson today. One of them, we've looked at how we locate the position of points along position of points on the Earth's surface by using the ordered pair. Then number 2, we've discussed how to identify a small circle and a great circle. And number 3, we have seen how we calculate distance along a great circle and along a small circle in kilometers and in nautical miles. So that is the basic of longitudes and latitudes that I want you to be able to understand for today. Keep on revising this topic because it's very important also in your syllabus and as you even prepare for your final exams at the end of the year, or as it may be defined within the course of the year. So that is all for now. Thank you for watching and thank you for being part of KUTV Elimu Live. Continue enjoying at home, practicing as you also do 1 or 2 in other subjects apart from mathematics. So from me, I want to wish you a nice day and enjoy your viewing of other programs on KUTV. Thank you and see you next time.